Hi everyone, welcome to today's webinar on OSHA's Process Safety Management Standard. We're glad you could join us. My name's James. I run webinars and events here at Triumvirate Environmental, and I'll be your moderator for today's event. And before I kick things over to our speaker, I just want to run through a few housekeeping items so we all know what to expect during this 1-hour event. Everyone's microphones are muted. You may have noticed when you sign on, but we do want to hear from you, so if you have a question for our speaker or a technical issue comes up, please use the questions box over on the right-hand side of your screen, and I will address your question. Following today's presentation, there will be an open question and answer period. A lot of information in today's webinar, and I know our speaker is going to do his best to save a few minutes at the end for questions. In the event we don't get to them all, we'd love to follow up with you in the next few days, but we'll take as many as we can. Also, we'll be announcing an offer at the end of the webinar, so be sure to stick around for that. And most importantly, we'll be sending you the slide deck and the webinar recording tomorrow. Keep an eye out for that email. Please introduce our speaker today, Rick Foote. Rick has over 25 years of EHS experience and is currently Director of Industrial Practice here at Triumvirate Environmental. Rick has been with Triumvirate for over 14 years, where he's established dozens of successful EHS programs for companies that had few or no systems in place. He brings client programs into full regulatory compliance, and he's able to customize these programs to individual client needs. And so with that, I'll turn it over to Rick to talk a little bit more about what he's going to present.
Okay. Thank you, James. Good afternoon, everybody. So today we're going to talk about the OSHA Process Safety Management Regulation. And the reason why we decided to talk about this one is OSHA has been busy on this one. And as you can see from here, the penalties for doing this, are quite substantial. There was a recent one that was $264,000, as well as OSHA has issued a new NEP, the National Emphasis Program, back in January, also around PSM. And as I have talked to a lot of clients, I've realized that some of them, are not aware of the rule or not sure about how the rule applies to them or if it applies to them. So with that today, I would like to kind of run through, like James said, there's a lot of stuff here, so this isn't a small rule, as if any of you are in the rule know that. So I'm going to try to briefly, as briefly as I can, kind of just talk about all the different elements of the rule and to see if it's applicable at your particular sites. So I guess we'll start off here is, why did OSHA develop the process safety management rule? And it really was all from past disasters. Some of these, you all maybe remember, but it really was that. And obviously we still have some current disasters. Right? We just had one recently down in Texas with the fertilizer facility, and there's been a bunch of other ones also, as well as they revised some of this standard or put the National Emphasis Program in, was because they perceived that there was some weakness within the program. So in order to kind of flex their muscles, if you will, they decided to say, all right, let's really push this so that people understand it and will hopefully do more with it. So some of these disasters, some of them you all may remember, Bhopal, India. Any of you that know me, I talk about that situation a lot because I always say that was one of the true stories of corruption and unfortunately deaths. And, some people call it the first terrorist act of modern times, but that one really was a big one, all the way back in 1984. It was also a great book, right, by George Orwell. And, I have a few other ones up here too. And you see that, really why does OSHA write any regulation, right? I always say is, here in the United States, are we proactive or are we reactive? And truly we're more reactive, and this was definitely a reactive type of regulation, is to say, hey, we got to do something here to ensure that we're protecting not only workers, but people that surround these facilities where these types of materials are being used. So it was a combination type of rule. I hear this a lot too, though, because back in 1991 when this rule was released, we also got the risk management program out of the Clean Air Act was released both at the same time. They are distinctly different in many different ways. So I really want to make sure that everybody here understands I am focusing strictly on the process safety management part of these regulations and really not too much going to talk about anything with the RMPs, even though if there is enough of an interest, as James said, we can always do that at a later date. But I really, really wanted to take the time and focus more on, what do you need to do and how do you do the evaluation first, which is the key to understanding this program, is the applicability of it. So when they put this all into place, the whole idea of the regulation was intended to prevent things like Bhopal or any of the other incidents that you want to talk about. And it was all around the toxic reactives, flammables, and corrosive chemicals. I mean, you see that a lot of facilities or even certain states have already enacted kind of, I call it quasi PSM regulations, where they've added to it, like where we're from, Massachusetts, they have one here too that they call it a process management regulation, which is different than OSHA's, but it's very, very similar in nature, but it's all about how the materials are used. So there has been a major focus on this, and obviously as the times have changed, I only see this probably getting stronger and a stronger regulation, because we are talking, in most cases, larger volumes of very dangerous chemicals. So you can only imagine, when we talk about it like that, is unfortunately with the word terrorism out there, right, we have to, bring that into play and mention it, so I can see this rule potentially getting stronger. So what I want to do, which is really what the whole crust of this seminar will be, is all around what is required for a management program. Because, once you get into this, I always say this program is not for the faint at heart. There is a very, very large part of this rule that takes a lot of time and a lot of effort for you at your facilities to ensure that you are in compliance. And I know I have spoken to some of my clients where they're like, whoa, this is huge, and, there's a lot to it. And I completely agree. So what I want to do for the next, roughly 40 minutes, 35, 40 minutes, is kind of talk to you about what are those elements. What do we need to know? What do you need to understand? And with any of the rules, here it is. And as you can see, if we look at, and most of you, I'm sure, are OSHA experts, right? You're probably all shaking your heads, but this one is, as you can tell here, has a lot of parts to it versus a typical OSHA program, where it's more or less like, okay, how does it apply? What do I need to do, and how do I do it? And in this one here, you can see is that there is multiple elements to the standard, which I am going to briefly touch on most of these, as we go through this, just so that you kind of get a rough understanding of what does it take. Because, everything from the training part of it is essential in this program. Coming up with the, how do you, the diagrams of how does it flow throughout the process. And, and OSHA on their website gives you some, some great examples of block diagrams or flow diagrams, because you have to understand how it runs through a process. So the whole entire thing is quite involved. And, I really want to kind of hopefully have you understand at the end of this, okay, does it apply to me? Hopefully for most of you, you're going to figure out and say, whew, it doesn't apply to me. That's great. But if it does apply to you, or if you already have it applicable to you, I'm hoping that you can kind of go back and say to yourself, okay, this is, what I need to do, and now I need to be concerned with it. So with that, let's talk about the application of the rule. So the way this rule is written is very simply, as you can see here, is it tells you here that any companies that use chemicals found in the Appendix A of the regulations, you're part of this standard. Okay, and in Appendix A, a lot of people will say to me, oh, Rick, that's a 10,000 pound rule, right? And I go, well, it really depends, It depends on the chemical. Every chemical has its own distinct amount of material that you have to have. For an example, anhydrous ammonia is 10,000 pounds. So a lot of the focus recently has been around like refrigeration systems, things like that. But I also say to people, well, do you have an ice rink, and do you use ammonia for, for the brine solution, that sometimes you could be exceeding the 10,000 pounds there. So it really comes down to what are you using and how are you using it. And Appendix A, it's a pretty good sized list of chemicals that you need to go through. It's roughly 4 pages long. And, things like acetaldehyde are on here at 2,500 pounds. So you have to go through this list and say, okay, what do I have? How do I have it? And how much do I store? And then, because they've made this listing was all around these high hazard chemicals that they're worried about that could cause some type of catastrophic event if they were ever to be released. So as you can tell from this, the list is, like I said, it's a pretty good sized list, and it is something you want to look at, but don't, as with anything, I always say to everybody, is always make sure you read the chemical abstract system number to make sure that the version, they call it a version of the chemical that you have, actually matches up with the materials that they are talking about within the standard. So as I said, here's an example. Here's an example of some of these that I put up here. Chlorine 2 is 1,500 pounds. Hydrogen fluoride is 1,000 pounds. And I can't stress it enough. Always, always, always check and verify the chemical abstract system number. And when you're looking at it, make sure too, that you're looking at your entire chemical inventory. And you really got to have a chemical inventory in order to do this appropriately. So that's the key to starting this process. So when we're also looking at this was an interesting, finding here too. There was an interpretation letter back in 2007. Is, again, it's all about that threshold quantity. And, sometimes people will ask, okay, what does it mean on site in one location? What if I have a location next door or, down the street or something like that? Is it really stresses here that when a threshold quantity is reached, when it exists within the area under control of the same employer or group, then it applies to that entire facility and area. So I know for some of you that may or may not be, a point of view, but it was something that I thought was very, very important that we talk about, because, you might have a warehouse right next door and say, oh, okay, well, wait a minute, it's not directly, it's a separate building, but it's like, no, this thing is kind of all one. So you really want to make sure you're looking at this appropriately for what you're doing and how you are doing it. So what types of industries are, typically in this type of realm here? Well, here's just some suggestions here. Obviously, chemical manufacturers, right? Again, if you really start to think about this, that's really what the rule was originally geared towards. And, but today, you got the pharmaceutical industry. They tend to think, oh, a lot of this stuff isn't applicable, but it really is geared more towards the pharmaceuticals in the manufacturing worlds, typically less in the research world, but if you got a very large research facility, it could be applicable. Again, you need to go back to the list, the Appendix A of the rule, and derive at what do you need or don't you need. So again, you got adhesives, sealants, and fibers. You can read all of these, right? And again, I already stressed the food processing, which is a very, very common entity, but I don't want to leave out, and again, it's probably unlikely that a university or something like that would have large amounts of ammonia, for an ice rink or something like that, but they own an ice rink that has multiple, skating areas and things like that. So you've got to be thinking about what else do you own and what are you responsible for, because it could drag you in, without you even thinking about it. I just want you to look at the entire facility and not just one piece of it. So with any rule, right, I always say to everybody, ooh, how do I get out of this, right? Because I don't want to have to do this. And trust me, I always say to people, well, this is one of the rules you don't want to get into because of the complexity of it and how many different things that are really, really involved. So in the rule, it actually gives us some exclusions. And we don't have the time to go through all the detail of all of this. So I do want a precursor as we go along here to say, I just took out small pertinent pieces that I thought were very important to at least begin the discussion here on this so that we're all okay with that. And so with that is, there is some exceptions. You are exempt from the requirements when, again, it's calling out specific materials, right? Flammable liquids, again, if they're stored in an atmospheric tank or transferred without the benefit of chilling or refrigeration. So it kind of says, okay, well, maybe you can get out if you have that flammable liquid, and I would say, there's always more information that got to go along with some of these, but it is a great starting point for you to say, hey, this may work. I might be able to get out of it. Again, kind of very similar to a lot of other rules, right? If it's there as a fuel, you might be able to get out of it. Okay, but if that fuel is going to part of a process, that's covered by the standard, then you may not be included in it. That's why I'm saying that you got to really look at every single part of this before you can say, okay, I'm out or I'm in. Is you really, really want to rip apart that chemical inventory. How is it used? I tend to like to say to start is really, okay, figure out what chemicals are applicable to you, do a process flow diagram about how that material is used throughout the facility, then come here to the exclusions and say, okay, can I somehow find my way to get out of this? And, do it within the rules and checking other letters of interpretation to say, yes, I am okay. So that is something that, you may want to think about. With that said, okay, if you decide or determine, I should say, I wouldn't say decide, right? That's definitely a bad word. I don't know why anybody would decide to want to get into this program. But let's say you're into it. One of the first things you really want to do is, and you're required to do this, is to get employee participation. So very similar to other things that we always say here, you want to form a committee. You've got to get people that understand all the different elements within your facility. And that is, you want to get people like process engineers. I always say the operators. The operators are the biggest key, I think, within this program, is because why? They understand it the most. They understand what things go on, what could go wrong, or what has gone wrong in the past. As Jay said, like, I've been here trying for a long time. I always say to myself, wow, I got a lot of historical knowledge about here. So those are the types of people, too, that I want to talk to at a facility to say, hey, maybe they had a minor incident that involved one of these chemicals, but it could turn into a major one. That's something you want to have, the discussions all about. And obviously, you can see the other ones here. Maintenance, you want to have management, you want to hire outside help, to do this with you also. Just some ideas. And I'm sure there's a lot more other people that we could add to this slide deck here. But right now, it's a good starting point at least. So from there, you have to write a written plan. So part of this is again, it's process safety management. So you got to have everything in writing. How are we going to do it? I always, I'm a Three Stooges fan, so I always say, do we cheat them and how, right? How do we document it? And also, how do we say that we did it if we don't put something in writing? So when you're developing the plan, what you want to do is you want to outline, most importantly to me is what is the responsibilities? What do you expect the people of that committee to do for you? Okay, and then what are their duties? What are they going to be? What type of reporting? How are they going to report back to you? How are they going to get you information? How are you going to have document control to know that, okay, we have a process and we didn't, somebody comes along and changes part of that process that could have an effect on this plan. How does that information get conveyed back into this entire program? And you have that type of document control. You've got to set up like progress reports. Where are we at? When are we going to be done? Where are we going? How are we going to get there? And how are we going to track all of these other changes? Maybe it's personnel. Maybe it's committee members. Maybe it's, again, like I said, change of chemicals or change of process. You want to have a program or a place inside of it to be able to say, yes, we did this. We got it all right, and we know what's there. From there, you got to look at, again, do this hazard assessment, which is all about, all right, what do we got? How do we do it? Where is it? And then compare it to the list. It really seems so basic and simple, I think, this part of it, but this can be the most complex part because, you got mixtures, you got other things too that, ooh, wait a minute, we're going to trigger it based on this, that, or the other thing. So you really, really, really got to get in the nitty-gritty and in the weeds here to make sure that you've collected all of the right information. And then once you got the volumes of the information, then you can move forward and say, okay, now what do I got to do with that information? So with that said, it comes into the next part of this, which is collecting the toxicity information. And with the toxicity information, the standard requires you to determine how toxic is that material that you have. And today, again, you got to remember, back when the rule was originally promulgated, we didn't have a lot of the data resources that we have today. And I always say to everybody too, I always caution, because it's like, there is other web sources out there, but remember, where are you getting that information from? Who put that information out there to make sure of the accuracy of it? So I strongly, recommend here that you use things like the safety data sheets that you already have. Most of you may be familiar with the NIOSH Pocket Guide, of hazardous chemicals. That's a great one. ACGIH, the American Conference of Governmental Industrial Hygienists. Somebody say that 10 times fast. And also there's plenty of other web resources out there. You got ToxNet, you got, so many other different outlets out there that you can, you can look at and refer to collect data on some of this stuff that you may or may not be as familiar with, but you want to be familiar with, because that's going to help you to figure out, all right, am I in this program or am I not in the program? And then figuring out, all right, what do I need to do to ensure that nothing really bad happens as you go down the road here. So what type of information do you got to collect on all of these chemicals? Again, I want to stress, these are for your regulated chemicals. So if you find out that you have more than one regulated chemical, then you want to do this. Even though I would suggest, hey, maybe you do it for, anything that you have that's even close to being, the threshold quantity or the TQ, it's never a bad idea to look at that also and say, hey, at least I'm collecting that data, because what if tomorrow we change a process and now we're over on that material? At least you've already done all of the homework. So as you can see on this slide here, we want to know about permissible exposure limits, your physical data, your reactivity, corrosivity. You kind of understand, and most importantly, I think, is the last one here. What happens? Do you have any of these materials that could react violently with the other material that's regulated? So you want to be looking at also any types of incompatibility issues that you have at your facility, and then kind of play out, because this is a lot of what ifs. It is a lot of that doomsday scenarios. As I always say to people, I try not to be the doomsday, preacher here that, oh my God, the world's going to end tomorrow. But there is times where, in this case here, we do need to look at that, because these are the things that we're trying to prevent at all costs. If we absolutely can, that is what we would like to do. So that's a major part of all of this, is collecting this toxicity data. From there, we're going to look at all the processes, right? What do we got for technology on how we do this? So what do we mean by this, or what does OSHA mean by this, right? Is they say the facility needs to develop, as I already mentioned this, it's kind of a block flow diagram, process flow diagram, whatever word you want to use, that really traces how this material goes through the facility. How does it work? Where does it go? How does it, what is the dangers? Is there potential in there? My favorite word is potential, right? Is there any potential of this stuff coming in contact with something that it doesn't like? And, really figuring all of that out. Plus knowing, okay, do you have any controls on how much of an inventory you're going to have of these materials? Sometimes, and I remember I had a client once that was getting close on this, and they're like, no, we're going to make sure that we don't come, we're just under the, the threshold quantity for the chemicals, so that we make sure that we're not going over it. And then they realize that they could cut it back even more substantial than that. So that's stuff that you want to look at, and then figuring out what are the upper and lower limits of that. How much do you normally have? Or how much can you have less of, or anything along those lines? And then also, what are you going to do if you exceed any of this stuff, or you deviate from anything you said you're going to do? So again, it is doing that pre-planning out and saying, okay, I need to do this, I need to do that, I need to figure out how to, move around in this program. So already you can probably see that, wow, there's a lot of little things that I have to do. And there truly is. There's a lot of stuff within this process. So some of these next few slides I'm going to go through relatively quickly just based on time. But, you know, like you also have to look at all the equipment that's in the process. This can be, in my opinion, this can be sometimes the hardest part of it all, because you may not have any of this data, or it might be harder to find because you're at a, you know, an older facility. So sometimes the older facilities have, you know, you may not have all of this data ready available, kind of like, you know, what's the materials of construction of it. You might be able to guess, but you may not have it. You know, do you have any, what types of drawings do you have? You know, the electrical classifications, what relief system designs do you have in place? How do you do that? What about the ventilation? What codes did it follow when it was being done? You know, and what types of safety systems? Some, like I said, some of the older stuff that we look at is not as safe as things are today. They don't have all of the quote-unquote safety features, so it can get a little bit more difficult for you to be able to, you know, figure out all of this information. But it's an integral part of the process that you must do this to ensure that you collected all the right information. Then you have to look at, you know, the mechanical integrity of the equipment that you just looked at. So what do we mean by that? It applies to certain pieces of equipment that we were just reviewing. So now we made a list of all of the materials that, you know, I'm sorry, all of the machinery that's involved. But now we're going to look at it and say, okay, do we have, are any of these instruments here part of that, you know, especially here like pressure vessels and storage tanks, right? If we're going to do a doomsday scenario, probably the worst thing we want to do is have a tank explode, right? Is because that is the worst case scenario, so that's why they're looking at those. And then what about the piping systems, right? Most times it's not a problem with the tank itself, is historically, if you look back at even the Chemical Safety Board or anything like that, when they look into incidences, they always say, oh, what usually it is what? More of a piping or a valve release or something like that. So that is some of the things that you really, really want to look at. And when you're doing that, you want to make sure you're looking at, you know, the shutdown systems. Do they work? Are all the controls? How old are they? When was the last time you tested them? Things like that, is because that's all very, very, very important to know and how to maintain those. So what do they make you do after that? So once we figured out, all right, where all this stuff is in the program, now we have to put written procedures again. So how are we going to maintain that? So how are we going to make sure that, you know, that Joe Welder is, you know, hey, or, you know, you got a, you know, structural engineer that says, hey, I'm going to change this because I think that in the process we can change the way the piping goes. Well, that could have, you know, a very strong problem or cause a problem in the process. So therefore, you want to make sure that that's well documented, because you also got to train all your employees, you know, that are maintaining this equipment about what they can and cannot do. So then from there, you got to make sure you're conducting inspections. Okay, we'll talk about that a little later. But inspections is a huge part of all of this too, is to make sure, you know, if any of you are ISO, I say this is very similar to an ISO process, plan, do, check, act, where you're planning it, you're doing it, you're checking it, and if something's wrong, you got to act on it. Once you get back to there, you're going right back to the start of the process again too, right? And saying, now I got to start the planning process again, and I got to keep going around in a circle just to make sure that I'm constantly meeting all of the requirements. All right, PHAs. You know, this terminology is thrown out there a lot today. I hear this term a lot for different entities, you know, of work, but in my opinion, this is truly the hardest part of this entire process. Okay, well, because we've already figured out, all right, now we know, all right, are we in the program? Unfortunately, we couldn't get out of it, right? From there, we started to putting together our process flow diagrams about how the materials flow through the facility. We've looked at the machinery that we got part of it. We looked at the integrity of that machinery. But now we got to figure out and say, okay, what could happen? Okay, and these, I cut and pasted this right out of the regulations because I thought it was the best way, you know, to kind of really lay this out. Is it says here that you have to do an initial hazard evaluation on all processes. Okay, but look at the way they word this. The process hazard analysis shall be appropriate to the complexity of the process. So they understand OSHA didn't turn around here and say to you, you must do this way. They said, okay, you gotta be as complex as the process itself. So that always makes me a little bit nervous because that's very subjective, right? That can be very subjective on the person that's evaluating what you're doing and how you're doing it. So back to that documentation piece is, I always say you really, really, really want to document well, why did you go the route that you went? What was the justification? Back to our committee earlier, put it out in front of the committee and say, all right, how complex do we need to go? Is this really, really detailed, or can we make it a little more simpler? Again, document every part of that because it will help you in the process as you go along. And keep into consideration all of these things, right? How many people are going to be affected? Who's going to be affected in the surrounding areas? Things like that are all an integral part, okay? Then from there, you got to determine and document and prioritize how are you going to do this, okay? How much are you going to do? How are we going to do it? And why are we going to do it? And then from there is how do you do this? Well, OSHA says you have to follow one or more of the following, which is, you do those what-if scenarios. So what if that tank ruptured? But, when you're looking at the what-ifs, too, it's not just saying, okay, well, what if it did? When did it do it? Is it in the middle of the day, in the middle of the night, or, is it on a weekend? Or, what if it was at a peak time, or when can it go? Things like that. They also, you can just develop a checklist to say we analyzed all of these different types of steps in the what-if scenarios. That's why we have the what-if/checklist. Okay, you can do a HAZOP. Is what are we doing? What are the hazards, and then what is the operability? How do we do that? And then the failure mode and effects analysis, which is one I've done, is said, okay, hey, if this did fail, what are the effects of that? So sometimes it could be doing some type of dispersion modeling, depending on the complexity of your facility. Is you might have to do, some type of like Cameo or Aloha or any of those, types of a data check to say, ooh, okay, if that pipe ruptured and this happened and where did it happen, is that we might have a plume cloud that could go here. Well, that's part of your scenarios, and you got to figure it out and say, ooh, okay, we might have a problem here. Danger Will Robinson type of a, scenario that you want to worry about. And, it also gives you the out, right? It says an appropriate equivalent methodology. So, again, if you can sit there and justify and say, okay, this is what I want to do, and this is why I want to do it, and this is, all of the different scenarios that we analyzed, that's fantastic. That's exactly what we want to do, is to, make sure that we've documented every single part of this so that we didn't miss something. So, you really want to document. You're not going to hear me say that enough, but it is a big part of it. Okay? So, don't worry, kind of like those infomercials, right? Here's those infomercials for you. Wait, there's more. If you order today, today's free is, well, it isn't quite that way, but okay, there's all of these pieces here come with it too. And like I said, I'm going to, we're going to briefly go over some of this stuff, but I think it's very, very important that I want you to understand that there's a lot of pieces to this. And of course, we have to say it, right? There's got to be training, safe work practices, emergency planning and response. What are you going to do? Do you have a spill response team? How many of you that do have a spill response team and then find out that you're in the process safety management program have actually taught your hazmat team about your PSM program? Because the two are interconnected, and they should be. So that is something too that, when you look at these programs, you say, well, how come that wasn't mentioned in the training? That you have this program or plan in place. So it is something, to think about. But let's just quickly go through some of these. Like I said, I can't, we just don't have the time to go through every one of them. So I did pick and choose just certain ones that I thought were important, which is, we see this a lot, MOCs, as some people call them, right, is the management of change. And this is to say, how do we do it? What if we change something? How do we change it? What do we have to, is it a process chemical? Is it the technology? Is it the equipment? Did we upgrade some of the procedures, the operating procedures? Did we change something at the facility that could have affected this program? Because if we did, we got to do something about it. Okay, and then what do we got to do? We got to document all of that, right? And to say, okay, what was our technical basis for that change? And it wasn't that, John slept at a Holiday Inn last night and now he feels like he's a chemical engineer. So we really want to make sure that, you're looking at everything. What is that impact, right? What is the impact to everybody involved with this? Was there an impact? Is it a good impact or a bad impact? Did you have to change PPE? Did you have to change, anything else? Did you, when are you going to do this? Did you have the paperwork trail? Remember we said document control earlier on also. Did you have that authorization here of change to say, okay, this is how we did it, this is why we did it, and that yes, whoever we authorized to sign off on it has signed off on it and ensured that things are correct. So it is a kind of a process here that you need to go through and in order to make sure that everything's correct. You got to have the operating procedures, right? And again, this is, their words, not mine, right? It clearly says that are clear instructions, clear. I don't know about you guys, but, sometimes when you get instructions, you sit there and you go, what? And typically, right, like at Christmas time, when you got the instructions how to put something together, most of us don't look at them, right? So you really want to make sure, this is where I say you want to get your employees involved. People that are actually going to do it. Put it in their language. Put it in this, know-how so that they understand it, because who's going to be looking at it the most? Them. And, and then just make sure it meets all of the requirements, of what needs to be done, like it says here. What are we doing? What are the limits? What did you look at for, for safety and health considerations? Because, again, all the way through this, right, what's our number one concern? Is the safety and health of our employees or anybody that's in those areas, God forbid something was to go wrong. So all of your, the operating procedures have to cover all of this at a minimum. Okay, everything from the initial startup to normal to temporary to emergency shutdown. I've seen emergency shutdowns too where people say, oh, I hit this button. Right? And I go, all right, so that closed every valve, every electrical outlet, everything that could potentially go in there and control temperature, or is it pressure or whatever. So you really got to get into that detail. Again, what are you going to do in case of an emergency? How are you going to do startup again? What happens if something didn't go right? Back to back to the earlier, the hazard analysis, your process hazard analysis, it's going to tell you how do we do things, okay? And then what are you going to do if you had to correct, or how do we avoid a deviation? So what safety devices did you put in place to make sure that some of this stuff would never happen? Because that's really the key here, is to say to yourself, okay, I got to make sure that, this can't happen. And we got to do our best to make sure that it can't happen, and we will, go from there. All right, so then you got your standard operating procedure. Again, more of them, right? Look, they got very similar to a safety data sheet, right? They got to be ready, available for your employees to see. They got to be reviewed to make sure they are current. So, I typically like to say, hey, an annual, thing is great, but sometimes, depending again back to, remember what it said earlier on the PHAs, depends on the complexity. So at a minimum, you're going to do it annually, right? But maybe in your facility, it might be every 6 months. Makes more sense is to do that so that you, know that you have it correct. And, if you're a chop shop, as I like to call it, right? As somebody that's constantly changing processes, you're making different products for different clients, well, that may mean that you got to look at these on a more regular basis than just annually. So it is something that you want to take into consideration as you are going through this process. Okay, again, so then you got to have safe work practices, right? This is, again, how do you do it? And this is where this rule will stretch out into other regulations that, you've got to be aware of, right? Because part of our PHAs and part of keeping people safe, Might be that we got to lock out or tag something out. We might have to do a confined space entry. So then we get into what? Personal protective equipment too. We have, you might get into welding, cutting, and brazing. You might get into, the hazardous chemical rules. You're definitely going to get into HAZCOM. Okay, so your HAZCOM program should also have some some direction, not illusion, that was the wrong word, but, some direction back to the, into your process safety management program that says, hey, guess what? These are, really high hazard chemicals that we have another program that's tied to it. Also your emergency action plan. So I could go on and on and on here about all of the different regulations that could also be part of this program that you need to think about. So when you're picking that committee that we spoke about earlier, it's very, very important that you think about, okay, these people are going to be involved at some point too. So maybe we want to get them involved right at the beginning and not necessarily at the very end, which I see in a lot of places, is because then those people feel, one, left out, and then they tend to come in more kicking and screaming, as I like to call it, right? And then you lose a lot of that valuable input that they could have had to begin with. So this is a very, very important part of the process too. Then, of course, we have to do training, right? Everybody's favorite thing. We want, we got to make sure that, and the PSM standard, says it's required. And what do you got to cover? Again, you got to cover everything that's all of the processes that occur at your facility that are part of this regulation. So again, we're only, when you're looking at PSM and you're looking at the training of the PSM, you're really training them only to the processes that have the regulated materials. This doesn't mean you got to do, so everybody in the company, we got to cover on all the hazards at our facility and all that. Well, I say you do, but you're doing that under different regulations, right? So you might be doing that under HAZCOM or, emergency action planning or something like that. This is specific to say, okay, we need to make you aware we have a PSM regulated process here at this facility. We have it for this chemical. This is why it's for that material, which is around, again, back to the toxicity, and we did a process hazard analysis. And if, God forbid, something went wrong, this could happen, and we need to make you aware of it so that this is all rolling together and everybody knows about it. And as you can see here, it says, you have to do this refresher training at least once every 3 years, or if you find during your annual audit, right, because I'm going to call it an annual audit, but you saw earlier you had to do the review of all of your procedures and things like that, that it's not being complied with and that you're finding issues over and over and over again, then really you've got to do more frequent training. I've had clients that'll say, oh, we do it on an annual basis. Great, if that's what works for you. But it really comes down to you got to look at yourself and your own facility and say, okay, this is what I'm doing and why I'm doing it. And everybody's favorite, right, is we got to, the next, sorry, I got a little difficult there, is contractors, right? So we got to make sure that they know what's going on, because we may bring in contractors here to, to work on these types of processes, but we need to inform them, very similar to like confined space entry, right? We got to tell them all the hazards that we know. We got to talk to them about what do we know about it. Hey, we got to give them the training, right? Sometimes it's more of an abbreviated training. I've seen abbreviated training just for contractors, and I've seen them go through, if they're required to go through the regular PSM type of training that every employee goes through that's affected by that process. So it really, again, they allow you to do what it is, what you want to do with it, to understand and make sure that it's covered, like, with everything that's needed. So here's just some ideas of what we mean by contract work. Contractors that might do it, so just, it does not include, like it says, support services, things like that, that really not going to have an effect on the actual process of that system. So it's more around, the real heavy-duty type of work. Of course, I mentioned this earlier, right, is that you've got to have, obviously you got to have an emergency action plan. right? Under OSHA, every facility needs to have some sort of a emergency action plan, right? And in your emergency action plan here, this one's going to get a little more beefy, if you will, is than what a typical one would be if you were not in the PSM program, because you got to have it for the whole facility. And it's got to have in there for, it's got to have the provisions in here if you had any small releases of the high hazard chemicals. That's what HCHC says, is highly hazardous chemicals that we talked about earlier. And you got to have in your EAP is it'll talk about what are you going to do? What types of early warning methods do you have in case of a release? So that could be anything from an audible alarm to, strobe lights to, whatever you're going to use. Is it PA system? Is it, and then we're going to talk about what about the, the evacuation plans. How do you do that? Are people going to get out? Did you think about, okay, in your plan, did you think about, all right, this process could actually, if it ruptured and it leaked, it could actually go into one of those of egress. Well, that's got to be documented in your plan to say, oops, okay, we're going to have to redirect people to a different route to ensure that they're not literally going right through the release area. So these are some of the things that you want to get, put into consideration here. And, make sure that, as we all know today, the one above that, right, is trained on the meaning of the alarms, is because I'm sure some of you will shake your head yes to this, is when we pull the fire alarm, or my favorite word for it is the evacuation alarm, right? What do most people say? Oh, it's just a drill. No big deal, right? Or if it's raining out, really, I got to go outside in the rain or in the snow, or, right? Most people take it, too nonchalantly, that they don't take necessarily the, real importance of getting out quickly. That you really, really want to stress to them that if we had an alarm in one of these, processes that are involving the high hazard chemicals, really want to get out and get out quickly. So you can't take that for granted that it may be just a drill. So it's very, very important that you instruct your employees on that front. So from there, if something happened at your facility, okay, you have to, you must, as soon as absolutely practical, you have to start, the investigation into saying what went wrong, why did it go wrong, where did we fail, right? Because you should have already known what could fail, and you should have been looking for why it could have failed. So you got to set up, again, you notice here with this program, it is a lot of teams. As I always say, I like to call it the process safety, management. It's PST, process safety team, because almost everything we do is in teamwork. And if a contractor was involved, then you got to get them involved in this incident investigation, is to make sure, that you got all the right people in the room, and that you are really sitting there and going through and saying, yeah, we did everything we could do. And then you got to come up with a report. So as we said earlier, you got to talk about what did you do, when was the incident, when did you start the investigation, what did you figure out, and most importantly, what are your recommendations to ensure that this hopefully will never, ever, ever happen again? Okay, because typically when you get one of these types of incidences, it's pretty severe. It's it's not a good thing. It's a very, very hard thing to look at. So also in there, you have to, your whole system, you got to have a system established as part of this. This is kind of like, again, and I hate to go back to ISO, but I tend to think there's a lot of linkage to it, is like, your corrective action program. It's the same thing here, is you want to make sure that, all right, how are we going to do it? Who's going to do it? When are we going to do it? Do we present it back to our initial committee? And then how do we make sure that all of this information is processed, and to make sure that everything is done right? And then how did you resolve it? And then, how do we track all of this? So back to the document control, right? So that plan, do, check, act. Again, kind of, if you know that cycle is kicking in all the way through, and we're just making sure that everything is there. The best part of all of this, right, is now you get to do a nice compliance audit. So in order to make sure that your program is effective, right, is you've got to have it evaluated, at least once every 3 years, is to make sure that every part of this program is complied with. Hopefully, right, I always stress this, is hopefully, you did not have any incidences, and this is just really a routine, check the box, if you will, type of an audit, which I know they're not, they're much more complex than that. But it is really there to say, okay, what can we do? How do we do it? And how do we make sure that everything's there? And in order to do this, you've got to have at least one person that's participating within the program that's knowledgeable in the whole process. Okay, so you want somebody there that really understands how, what processes are affected, how are they affected, and why are they affected. You want them part of the audit program. Okay, you've got to have a report, and you've got to show that any deficiencies that were found must be corrected and then documented, and you've got to have the last 2 compliance audits must be kept on file. So that really means you got to have what, like 6 years, right? So you got 6 years, 2 cycles, which is 6, right? So you want to make sure that you have those in place for yourself, or if OSHA came in and they did an audit of you, that you have these documents in front of you. Very, very, very important thing. And I always say, to everybody too, if you do an audit, is take a look at, maybe you do the full-blown 3-year, heavy-duty compliance audit, but it might be helpful too, maybe on an annual basis, go back and say, hey, we had an issue here. Let's take a look at it again. Let's make sure it hasn't creeped in again. Why wait till the 3 years to do the official audit, if you will? Okay, there is a piece in here too, kind of getting close to the end here. I know I'm getting very close on time, so is trade secrets too. It also makes sure that, it does allow in here, that you can take, into consideration that, some things are trade secret, but they say, you know what, you got to make sure that you can't claim that. And, I was talking to somebody recently, like, oh, we don't have to do that. We're covered by trade secret. It's like, no, you still got to follow all of the regulations and all of the parts of the rule. It's just, you can put some confidentiality to some of it, but you can't just disregard it because you are, claiming a trade secret for this type of a process. So it is very, very, very important that you look at all of this. So with that in mind, as we said, we just really went through a whole pile of stuff here, and there's a lot of good information out there. There is a process safety management checklist that's put out by Georgia Tech. We have a link on here for you. Obviously, the OSHA website. The OSHA website has a ton of letters of interpretation, as letters of interpretation really are there to tell us how does this stuff work, what do they really mean, what is the purpose of it, and things like that. And one of my favorite websites, even though I always say we go there for the wrong reasons, right, is the Chemical Safety Board, website, because it actually tells us about real incidences. And it's great because if you have a similar process to what somebody's doing, you can actually, learn from their mistake, if you will. What I mean by that is you can go in there and it'll actually show, like, to say, oh my God, they had this catastrophe, but this is what we think the reason why it happened. And hopefully you can take that information and go back to your own facility and say, okay, let's look at that in a different way and say, hey, could that potentially happen here? Could this happen this way or that way? So it is something that we want to, share with you and say that is a great resource in which to look at. So with that, James, I am going to switch this over to you for questions.
Great. Thanks, Rick. And we do have a few minutes left for questions. I didn't see very many come in, but I want to remind you to type in your questions, and if we don't get to it right now, I'll make sure Rick and I touch base afterwards, and we'll get you some responses to that. So while Rick catches his breath, I think I'm going to just run through a few conclusion points. If you missed us at the top, I want to let you know that you will receive a copy of the slides and a recording of the webinar, and that'll arrive in your inbox tomorrow morning, so keep an eye out for that. We'll also send a link to a short survey. We'd appreciate your feedback on the webinar, ideas for improvement, and ideas for future topics. So let us know what you think. Also, as a thank you for attending, I mentioned we would make an offer at the end for a compliance review I'm going to shoot that over in the chat box if you're interested in learning more about this complimentary OSHA compliance review. So take a look at that while we're still on the line. And also, Rick, if we can advance to the last slide, I want to share your contact information with the group. You'll see Rick's email address. I'm sure he'd love to hear from you. And if you want to get in touch with Triumvirate, our phone number is listed there. So a few ways to get in touch with us. If you have any questions, let's get those in. Otherwise, we can probably close down in a couple of minutes, but I'll take a look and see if anything's come in. Yeah, lots of questions about getting the slides. So I know Rick presented quite a bit of information today. So I'm sure, hopefully you weren't jotting down too many notes, because you will get this. But Rick, I think we can conclude. We've got 2 minutes here. Do you have anything else for our audience today?
No, I just think, obviously, as most of you may know, OSHA has been very, very active. So this is just one of the topics. The new, slip, trips, and falls, right, is just kicked in. So, really just pay attention. And really the key to this program here is that chemical inventory and, determining if you have anything at your facility that may be, trigger these requirements. And, you really just got to follow it and make sure that you're compliant. So, and make sure to keep your employees safe. That's really what it's all about.
Awesome. Thanks. Great advice. And we'll close with one question. As a plant comes offline, Rick, when does PSM no longer apply?
Once they're below the if they're closing a facility, right?
Yeah, might be what they're referring to. Sure.
Right. So the facility is closing. It's really once they, once that process is closed down and no longer operational, then the program, obviously, that's no longer in effect.
Okay. Great. Thanks for clarifying that. And if anything else comes to mind, please get in touch with us. We're happy to hear from you. Yep. All right. So that concludes our webinar. Rick, thank you so much for presenting, and thank you, everyone, for your attention the past hour. We appreciate it, and hope to see you on a future webinar.
Thank you very much, everybody.
All right. Take care.
Bye now.